So, as I said, I'm Zdenek. I'm currently employed at Pure Storage. And I will be talking about Go 125 and what's new in this version. So it was released in August 2025, so it's a few months old. And there are no language changes, and it keeps on backward compatibility promise. The older I am, I more appreciate this. So yeah, I just want to emphasize this line. Not many other languages have it. So yeah, I think it's a great thing. So let's get to actual changes and the good stuff. So for me, it's mostly two things: JSON v2 and sync test. There are other things like a new optional compiler, some trace flight recorder, and other changes which I don't want to go into. So if you are interested in those, yeah, you are on yourself. You need to help yourself. I will be speaking about these two, JSON v2 and sync test today. So let's get into it. JSON v2. So it's experimental in this version. So you need to run it with Go experiment variable. And it's incompatible with JSON v1. But mostly it will work as a drop-in replacement for you. So it's good. There are some changes like in some cases it will return error where in v1 it wouldn't and things like that, but in 99% of cases it should be drop-in replacement. So two things, performance boost and new API. Performance boost, I don't care that much, honestly. There are guys who did benchmark, and we can see. I recommend you guys to just go through it yourself if you're interested in performance. They made a really good job, but in various cases it's always 1.6 to 3.6 faster than v2, and sometimes even 20 times faster, right? So performance, good. And why there's performance boost? It's mostly because it's done in a streaming way. So if you go really into low level and how it's implemented, in v1 of JSON, when there is marshalling happening, it reads the whole object, the whole file before it starts to serializing data. Now it's streaming, so it goes like line by line. So it's much faster. And new API. So I prefer to show the new API in live coding. I was thinking how to show this the best. And I think I like when there is when speaker struggles with live coding. So that's what I'm gonna do. So bear with me. I have cheat sheet here, so you will see me to look into that sometimes. But let's go to code. Yeah. So let's show the JSON v2. By the way, I'm running this with Go experiment / equals to JSON v2. I will show you later. So let's start with simple user. I'm using some AI, so it's there. But it's not what I need. I need age, omit 0, and I need tags, which is omit empty. So here I want to show you tags. Tags are, and by this I mean JSON tags, not the field tags. Omit 0, omit empty. It's the same as in v1. There's no change. I just want to get this running So I will just create new user instance like this, and let me run it. And let me make it bigger. So I will, as you see, I'm running with Go experiment variable, and it shows. Oh, I'm showing the wrong thing. I meant to serialize this data first, which is data error, and now the JSON Marshall comes to play, but we're not gonna use JSON. We're gonna use JSON v2. Immediately, you see it's the same API. If I hover over this, you see there are some opts which wasn't there before. That's the new API, and it's optional. So that's why it's drop-in replacement. You can use the same code from v1. Let's run it again, and it shows nothing because it's omit empty and omit 0. Let me show you some new tags and how they work, because I think this is really life quality improvement. So we're gonna define exactly the argument. I'm using argument, by the way, AI, so it knows what I want to show you for some reason. So we have let me define few dates. We have registered at, and you can see the new thing. Format here, that's the new tag you can use, the format, and then you can put there a value. So for instance, here I put RFC 3339, which is the date format. And let me just quickly enhance this thing with time.now. And when we run it, you can see this is the RFC format. Let's go further and let's define updated at, and we define format. And here we can put the Golang format. We don't need to use the RFC. We can use our own format, which is defined like this. Let me put it to this guy, and you see updated at is like this. So it shows the real format as I defined. Now let's use as I told you before, there is the new API for the JSON Marshall. The options we can have some. We can put there some options to formatting. It tries to give me this with intent, but I want to use the multi-line option. It should be multi-line. No, it doesn't want to. Oh, because it's from different package. So there is another package called JSON text, which is also new. And it basically means put everything to the new line. And when we run it now, it's on a multi-line like this. So to do this in V1, we would have to write I would say a lot of lines of code or use some third-party libraries. So this is definitely better. Let's go further. We have updated as, and it knows what I want to do. That's amazing, actually, because I wrote this in a different project, so I guess it learned what I want to do. So now this is duration, and you can specify the format of duration as well. So this will print in nanoseconds, or we can do seconds as well. And if we do duration, so let's do this, which is time since 1 hour ago. And if we run it again, it crashes. Because seconds is not defined, I guess. So let's go back to what nanos also doesn't work. I guess it's nano. It's nano. So in that case, second should work. Like it's singular. No. So nano. You should. Let's let's be happy with nano. What else? Okay. So this is useful. Another useful thing is stringified numbers. So sometimes you need to encode your numbers as a strings. So this is how you do it. You define it as an int, and then you put this string tag here. So we put score 1, 2, 3, and if we run it, it's in quotes. So sometimes it's useful. Then we have the struct inlining. So let's define address, which is another struct, and let's define address here and write it like this. But by the way, if you don't know this notation, it's the same as in V1, but this means use default field names, which in this case it will be address. So it's just like this, and the tag is inline. So we're gonna add address here, and we're gonna run it, and you see the address is inline, so it's like this. Moving on, we have another useful tag, which is useful for the other way, the unmarshalling. So it's capturing the extra parameters, extra data. So let's expand on this. We're gonna, it really knows what I want to do. Yeah, this is exactly what I want to do. I don't have pretty print. Let's define pretty print function. You see how live coding gets easier with AI, sort of. Right, so what we are doing here is we have the raw JSON defined as a slice of bytes, and we are unmarshalling this to the U2. And what is extra here, you can see, is the meetup going, right? So if we run it, there's extras, which has meetup Golang. It has also updated it, and duration nanos, because that's also extras. It's not defined here. Yeah, updated it is actually here with the capital, so that's why it's also got to extras. Yeah, so we have and we did it by defining it like this. So it's a map string to JSON text value, and the tag is called unknown. This can be also, it should work with any. Let's try it. It should work with any, I hope. Okay, I was told we are 10 minutes in the presentation, which is actually great because I just ended this JSON showcase. Maybe just on, in this Marshall, what we can see, there's like a lot of options we can pass. So I definitely encourage you guys to have a look and play with it yourself. Because multi-line is one thing, there was the indentation as well, which is similar. It's just you can put like your indentation and stuff like that. So JSON v2 improvements, I haven't got to, there's like more, you can define your own marshalling in like stream way. So you can, for your object or struct, you can actually define, custom marshalling in much more granular way than with V1. So yeah, in general, much better than V1. Okay, let's go to back to presentation, which is next topic is sync test. So sync test is a tool for deterministic testing of concurrent and time-based code, and it can replace a lot of existing fake clock libraries, and it should bring clarity and determinism in testing concurrent code. I'm not 100% sold on this actually, because it brings some magic to Go, which I think the language is something stopped. Hope it's good. Yeah. Yeah, I'm not 100% sold. I will show you live coding again, but yeah, for me, Go is something which there's no magic. You always can go to source code and go deeper and deeper and understand what's going on. This brings a bit of magic to me, but I will show you, and you can make your own opinion. So let's go to sync test showcase. Okay, I bootstrapped this in the wrong way. We need actually a different file. We need, I didn't expect this. I'm seeing the purple screen. But it works like here. I need my, let's do like my underscore test. Let's hope it works. I'm back. Good. Package is the sync test showcase. So we're gonna write test, which means we need test syntax basic. Yes, that's what we need. So let's write a simple test, which you guys all know. So let's write that we have a variable assigned to 0. Man, it knows what I want to do. So we have test. Let's run it. So the test, just to see what it does. So there is go func. So this is asynchronous, right? And it just goes over 1 million and it increments the x and it logs the x. Let's run it. Go run, and we have, it's called sync test showcase. Sorry, you are right. We need go test. Go test. Let's put v, and we need this. So what's gonna be? What is the x? You see it's 0 right here. So it's wrong question. But the real answer is you don't know. The x can be anything from 0 to 1 million, actually. Let me write it like this. I like this better. So this can be actually anything from 0 to 1 million, because if, let's say that we go through these lines and we are here. At this point, this can either be scheduled and executed or not. If it's executed, then it can be literally 1, 2, 3, 5 million. If it's not executed, it's 0. Mostly it will be 0 because this won't start, but you are not guaranteed. And that's why the Go team introduced the sync test package. So let me just improve this. So we enhance this with much more determinism. So we're gonna write synctest.test exactly as this once. We need to the whole thing, put it the whole thing into synctest. It's looks similar to. We need some brackets, I guess, like this. No. Synctest.test. Let's. Thank you. And we need to, of course, import. This is not experimental, so you need to write it with the experimental flag parameter. And now, if we run it like this, nothing will change actually. This looks, I wanted to say this before, this looks similar when you are running the like subtest, right? You can do it like this. It looks very similar to this, but it's different. There's a new thing called synctest.wait. Looks similar to waitGroup.wait, but it's not like this. It's different. What it does, and that's the magic part I was commenting before. It, by definition, it says it waits for all Go routines, basically all Go routines to finish their work. So it somehow uses the runtime to understand the Go routines running, and when all Go routines waiting for something, they call it durably blocked. That's the term they are using. Then it basically stops blocking and continues. So now you're guaranteed that this will be million. So you see here it's million. It was 0 before magic. So yes, you could write the same thing with channels before. Basically, you could somehow, or wait groups. You could run it. Where this is powerful is when you are testing code where you don't want to change the source code, and you just want write test. You don't want to change source code, so you cannot like add some channel or synchronization primitive there. Then it's useful. Yeah, but you could write the same thing with channels or other mechanisms. Sorry. So I have more. Synctest can do more. There is also, I originally said, it also helps with time. So let's write synctest with time. Oh, I had to open this the whole time. Okay, well, doesn't matter. So write time sleep for 5 minutes. But under the hood, it uses fake time, so you actually don't wait 5 minutes. So if I run it, it passes immediately. You see, so we are not waiting for 5 minutes. You can achieve this in before synctest by using fake rock libraries. So you need to like put you don't even need fake libraries, I guess. But you need to use basically, you need to inject your time as a parameter and dependency, and then you need to solve it like this. So for testing some old code or convenience, I guess, when you don't want to introduce a new library or something like that, this can be very useful. How much time? Okay. So in that case, I'm going to skip the last coding part I had. Just quickly I will show you one more test, but I won't write it, it's longer. But before that, let me just, one more thing. The new thing is d.attr, like attributes, which is a new thing you can do. It's basically just marking your test. If you run it, it will mark your test with what I just wrote there. It's even, if you run it as with the JSON output, it's also somewhere there. cannot find it now. But this is useful for your CI runners and stuff like that. If you want to like categorize your tests or I don't know, mark it like say this is unit test, this is functional, this is integrated. Like you can use this ETTR. I know that we in Pure we are using some third-party library for this, so I guess it's good that we have it built in. And to show you more real-world example why this is good, let me go back to cache example test. Okay, I will just quickly go through this. So let's say we want to implement, we have implemented cache. This cache has expiration, like every value has some expiration time on it, represented like here. And we have set get methods, and it's basically if time is after the expiration, it returns false. And there is cleanup as well. But let's not talk about cleanup now. Let me show you. I have two tests. So one shows you the expiration of the keys itself. So we set some cache, and first we get some value which is okay. Then we sleep for half a minute, and you get the key, and it's still good because we put the TTL hour. Then we're gonna sleep for 2 hours, and we get it, and we should get the cache should be already cleared. So it passes. Right, so, and it was immediate because as I showed you before, the time is advanced automatically. So this is good. You can write sleep and still that's all thanks to sync test. And now the cleanup, as you here there is on the cache there is start cleanup, which runs cleanup on the background. Right? It basically there's ticker, and whenever the ticker ticks, it runs the cleanup, which goes through all keys, and if it's after the expiration, it's gonna delete it. So how to test this with sync test? Quite easily. We gonna start everything. We're gonna start the cleanup. We're gonna set the key, and here we are waiting. So again, this is advanced automatically, but it's like 1 nanosecond before the cleanup interval. We're gonna wait, which means we're gonna wait on whatever internal stuff, whatever Go routines are running, and we're gonna check. And in this case, the key exists because it's 1 nanosecond before the cleanup interval. And remember, this is the good thing about sync test. It's the time advance is deterministic. You need to advance it basically by sleeping. In other words, so it exists even though the nanosecond probably passes before these lines, but still it's not. The key is there. Then we're gonna sleep the nanosecond, wait again, and we're gonna check directly the map, not the get method, but the map, and the key is cleared. So this shows, and as I showed before, I ran the test before, so it passes. It shows how the wait, sync test waits for all the asynchronous code to be executed and finish. And that's it. Let's go back to presentation. That's it.